wind, which is my field, with the Green Revolution's windmill, is an interesting dog. It is, by all accounts, the second oldest source of energy on the planet. The oldest, of course, being just plain fire from wood and carcasses and whatever else you had around to burn. Now, in the case of wind power, wind has generally not been considered a base load energy source, and that has been, until recently, a reasonable objection to wind power. The wind is capricious, depending on where you are. It may blow anywhere between a couple miles per hour or dozens of miles per hour. That wind speed is constantly variable. It is not reliable. It runs with the weather. It runs with the tides. Actually, it is a constantly variable source of energy. Now, the ways that people take care of this are, of course, number one, battery storage, as I mentioned with the micro hydro, and which can also be used with solar, and or by grid time, so that you're tied to the rest of the generating sources that are available in one's region. Now, the reason why this is the case is because the average wind power generator requires somewhere between 12 and 15 miles per hour to begin generating electricity, and between 15 and 20 miles per hour of wind flow in order to generate the rated amount of electricity that would satisfy the base load of a consumer, whether business or individual. In most cases of wind power devices, this is quite an accurate accounting of what happens with the wind power devices. Now, there are many kinds of wind turbines. They all do basically the same thing. The wind blows. The wind turbine, whether it's a Darius egg beater or whether it is a traditional Dutch-style horizontal axis windmill, a gigantic GE or Toshiba highly geared wind turbine offshore or onshore in the desert somewhere, they're all doing the same thing. The wind flows across the blades of the windmill, and it creates the equivalent of a lift. Same as the airfoil you might have exposed to you to show you why an airplane flies. And this creates locomotion. The blades turn. The axis to which the blades are attached in turn turns a transmission, which gears up the speed of rotation to the point where it is turning a permanent magnet alternator or generator, an electric motor, magneto, at a speed to where it pushes enough electrons down the line to provide enough voltage and amperage to run all the things that we want to run off of electricity, which, by the way, can be anything. I want to make it very clear that electricity has every capability to be the sole energy form that is utilized on this planet for everything we do. Whether we're talking about driving cars, running buses, running trains, even flying aircraft, we can use electricity as our sole energy source. The The choice is how we are going to generate that electricity. Now, I would propose that wind is the single simplest, economical, and most viable source of electrical generation that we have available to us and ever will have available to us unless we come up with some kind of violation of thermodynamics and entropy and create a perpetual motion machine. Now, there are two basic kinds of wind turbines. Number one is the horizontal axis wind turbine. That's what most people are used to. It's what you would generally refer to as a windmill. You have the blades facing into the wind on a horizontal axis, and as I said, they turn a transmission, quite often a differential to change direction of the rotation, so as to turn an alternator and pump electrons down the line. And they are the most common, and they are the least efficient. The reason being that they must be pointed into the wind, which can pretty constantly change. And those of us who have lived with the giant wind turbines for the past quarter century in Southern California know that anytime you pass by those giant wind fields, you'll see that about half of them are out of commission at any given moment. And there are a couple reasons for that. One reason is because the turbines just have not been pointed into the wind. Another reason is that because they have these highly technological and highly geared transmissions to take the slow turning energy from the blades and create fast turning energy in the generator, they need a lot of service. They need service and lubrication. Anything that's mechanical that has to suffer a tremendous amount of speed and heat and friction is going to eventually break down. And that is, unfortunately, a case of planned obsolescence on the part of the manufacturers. GE and Toshiba and Hitachi, just like any other manufacturer of heavy equipment, make things extremely complex and make things vulnerable to wear so that they will guarantee themselves an income stream in servicing the devices when they break down. And considering that most of these large wind power generators are